Okay, this is going to be a video. It's going to be on variations, really day 2. We're going to talk about how to identify a direct variation, an inverse variation, and a neither equation. Okay, so what you want to do, the concept of inverse variation is twofold. It can either look like this, okay, it's making up some number, okay, where it's xy times, or it's any time that you have x and y basically diagonal of each other in a fraction, okay? That's a fast way to identify inverse. For direct variation, the simple thing would be y equals x, or another way to look at it is when you have y and x on the opposite sides, but on the same level. Okay, like not a fraction. So as you can see, x and y opposite level, same level. Okay, all right. Now for neither, the big giveaway on neither is if you have a y-intercept here. Okay, because if you notice the inverse and direct variation, they do not have a y-intercept. Okay, all right. So let's go and look at some actual examples. Let's apply that same concept. Okay, all right. So some of these, all right, let me clean this one up here a little bit. -6. All right, so if we look at these, this one would be inverse. Clearly, x and y on the same side. This one would be direct. Okay. And this one, since it has that y-intercept, that would be a neither one. Okay. This one has x and y on the opposite sides, same level, so this is direct. This one has x and y diagonal each other, so that's going to be an inverse. This has x and y diagonal of each other, so that's going to be an inverse. And since I have the y-intercept there, okay, that's going to be a neither. Okay? All right, let's go through a couple more examples with that. Okay? All right, so let's look at these. Okay? This is x and y, same side, this would be inverse. Okay, same level, that'd be direct. Okay, that has that y-intercept, so that's going to be neither. X and y diagonal of each other would be inverse. Okay, here's another one with a y-intercept, so that'd be neither. X and y diagonal of each other, so that's inverse. This one would be direct, because I got y and x, all right, on the opposite sides, same level. Okay, and then you can go ahead and practice those, all right, in Go Formative. Okay, all right. It says find the constant of proportionality of direct variation. Here's the big thing that you have to understand: that with direct variation, you always have a point in the origin. So I can automatically go ahead and make that point, and that will help me in a little bit. Now, to find the constant of proportionality, what we're going to find is we're going to find the slope, where the slope is up or down, and how many we go over. Okay, up or down, how many we go over. So take the elevator up or down. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I take 9 up, 1, 2, 3 over. Now, I want to reduce that. 9 divided by 3 would just be 3. All right, now, the big thing you also have to do is slope. Remember, if the line is like this, the slope is positive. Lines like this, it's negative. So if I were to connect the dots here, that line would look like that one, so that's +3. Okay, how do I make a direct variation equation? Very easy. Y equals whatever that is with x. It says draw 2 points, all right, in the same direct variation relationship. So this is like 3 over 1. So from this, I can go 1, 2, 3 over 1. 1, 2, 3 over 1. The big thing, it's got to go through the center, okay? All right, make sure you draw your relationship through the center. All right, find the constant of proportionality. So I automatically know through the center. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I got 8 over 1, 2. 8 divided by 2 would be 4. Now, if I connect those dots, that would be a -4. So -4, y equals -4x. All right, what does negative 4 over 1 mean? Well, from this, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, go the other way. 1, 2, 3, 4 over 1. Okay, bottom line is, has to go through the center. Okay? All right, let's look at this one. Okay, this would be up, elevator up 1, 1, 2. 1 divided by 2 would be a half. Okay? All right, actually I don't need that. 1 divided by 2. So if you ever have to reduce that in Desmos, go ahead and do that. Now, I got center would be right here. Okay? All right, so 1 over 2 makes out y equals 1 over 2x. So up 1, 1, 2, up 1, 1, 2, up 1, 1, 2. Okay, once again, you go through the center. All right, that's for you to try, All right, let's talk about equations of lines, okay? When I make an equation of a line, okay, it's y equals with an x, the slope goes here, the y-intercept goes here. Remember, the y-intercept is where it crosses the y-axis, okay? All right, so that's important, okay? That's going to be important for us, all right? So it says draw f of x equals x and g of x equals 3x minus 1. Okay, so what that's going to be, there's a 1 there, so no y-intercept, and I'm here. 1 would be up 1 over 1, up 1 over 1. Okay, so here's what my line looks like. All right, the g of x line, how would I graph that one? This would be at negative 1 here. All right, that's 3 over 1, so up 1, 2, 3 over 1. Okay, so is the graph of g of x shifted up or down? So this was my original. My original was at 0, so I went down to get that. So that would be down, down 1 in this case. Is the graph more steep or less steep? So let's talk about this. Okay, so if I have anything like this, all right, obviously if it's more vertical, this is this is more steep. If it's flatter, it's less steep. Okay, so if I compare, this was my original, okay, this is like that, so that is going to be more steep. Okay, all right, it's going to be more steep. All right, so once again, draw f of x as x. All right, so that's here, okay, this is what I got. All right, that's my original. Okay, now let's draw 1/3 x plus 4. So 1, 2, 3, 4, up 1, 1, 2, and 3. All right, so what happened from the original? It shifted up. Is it more steep or less? It's flatter, so it's less steep. Let f of x equal x. The graph of g of x is below. Okay, describe the shift from f of x. So, here's the idea. This is just, the concept is that is at the center. All right, that's what we've been talking about. All right, how is this related? So here's all we're going to do. We're going to find the equation of my line. All right, that's all I'm going to have to do on this. If you need to draw it, you can. You don't really need to, though. All right? So how do I find the equation of the line? Well, first of all, that's going to be y equals, we talked about this, x. I got to find the y-intercept. Where does that cross at? That crosses at -2. I'm sorry, not -2, +2. All right, so it's up 2. How do I get the slope? Okay? From here, I would go 1, 2, 3, 4 over 1. Okay? So 4 over 1 is 4, that's a positive line, so that's y equals 4x plus 2. So describe the slope compared to f of x. So if I compare this to this, if you notice, it's times 4, so it's 4 times more, okay? And then this, compare the y-intercept. Well, here my y-intercept is technically 0, so what is this? This would be 2 more. So 4 times x, that's why it's 4x, and this would be 2 more. So all you gotta really do is find the equation of the line, okay? So f of x equals this, find the equation below, okay? So I got y equals, all right, this is 1, 2, -3. Then I would go up 1, 1, 2, 3. So 1 over 3, it's a positive slope, so this is what I got, 1/3 x minus 3. So describe the slope. It's 1/3 times. okay? And this is going to be 3 less than that, okay? So don't overcomplicate it. All right? Describe the slope in this situation, okay? So what I want to do, we got y equals, this is at -8. This would be up 1, 2, 3, 4, 5 over 1, 2. So 5 over 2, okay? So describe the slope compared to f of x. It's 5 and 5/2 times, okay? Describe the y-intercept, it's 8 less, okay? So it's a little bit of a combination of some things we've done this year with graphing lines and finding equations.